No, this is mechanical engineering, equivalent dynamical system. So we are going to see here about the rigid body. Here, this is the rigid body. This is subjected to a lot of external forces. So the action of external forces, to determine the motion of a body under the action of external forces, the body is replaced by two masses. They are placed at a fixed distance apart. Right. So here, the motion of a rigid body, we have to determine the motion, find the motion of a rigid body such that it is subjected to a lot of forces. So we have to find the motion of the rigid body under the action of a lot of forces, external forces. The following conditions are to be satisfied. First condition, the sum of the masses is equal to the total mass of the body. That is, here the rigid body is replaced by two masses, m1 and m2. Total mass of the rigid body is m. It is replaced by two masses. Instead of considering the rigid body, which is under the action of several forces, we consider only two masses, m1 and m2. So here the sum of the masses is equal to the total mass of the rigid body. Right. Where it is applied, where this concept equivalent dynamical system is applied, it is applied in connecting rod, in the design of connecting rod. This is the small end of the connecting rod, this is the big end of the connecting rod, this is G, center of gravity of the connecting rod. So here in designing the connecting rod, right, this concept is applied. Right. Here, so this is the mass. This rigid body is replaced by two masses, m1 and m2. M is the mass of the rigid body. G is the center of gravity of the rigid body. m1, L1 is the distance between mass m1 and center of gravity. And L2 is the distance between mass m2 and center of gravity. Right? Total length L is equal to L1 plus L2. So we have to satisfy these following conditions. The sum of the masses is equal to the total mass of the body. Second condition, the center of gravity of the two masses coincides with the center of gravity of the body. The center of gravity of the two masses taken together, it is the same as the center of gravity of the rigid body. Third condition, the sum of the mass moment of inertia of the two masses about their center of gravity is equal to the mass moment of inertia of the body. This is the third condition. So these three conditions must be satisfied to replace the rigid body by two masses m1 and m2. L1, m1 L1 equal to m2 L2. From that I can write. Therefore substitute this here, m1 plus m2 equal to m. Substitute the value of m1, m2 plus m2 L2 divided by m2 L2 divided by L1 plus m2 is equal to m. Right? Therefore m2 is into L2 by L1 plus 1 is equal to m. So from this we can find m is equal to, right, take LCM here, it becomes m is m1, from this m2 is equal to, you can find out m2. m1 equal to m2 L2 by L1, substitute m1 value, therefore it becomes m2, right. So m2 is equal to m L1 divided by L1 plus L2. So this is one mass. The second mass, m1 equal to m minus m2, right, because m1 plus m2 equal to m. Therefore m1 equal to m value, m minus m2 value is this, m L1 divided by L1 plus L2. So simplify this, it becomes M1 equal to ML2 divided by L1 plus L2. So these are the, this is the two values of two masses M1 and M2. Next is M1 L1 square plus M2 L2 square equal to mkg square, right? Right. Therefore, substitute the value of M1 in terms of M, M2 in terms of M. It becomes M into L2 L1 square divided by L1 plus L2 plus M into L1 L2 square divided by L1 plus L2. So this is equal to M kg square, right? So this is equal to M kg square. M cancel M. Therefore it becomes L2 L1 square by L1 plus L2 plus L1 L2 square by L1 plus L2 equal to kg square. So simplify this, it becomes kg square is equal to L1 L2. Therefore, so this is kg, radius of gyration. Therefore, radius of gyration kg square is equal to L1 L2. Kg is equal to L1 L2 square root of L1 L2. So this is the radius of gyration. We can consider the rigid body as a, the connecting rod as a compound pendulum. Therefore, N is equal to kg square plus h square h. Where h is called the center of percussion. So you can use this. Here h is equal to, using this formula we can equate this is the length of a simple pendulum, equate this to a compound pendulum, right? H is equal to, here it is L1. Therefore, we can write L1 L2 plus L1 square by L1. Right. Therefore, it becomes here L is equal to L1 into L2 plus L1 divided by L1. L1 cancels, right? So L is equal to L2 plus L1. This is for the connecting rod. Right? We can equate the connecting rod to a compound pendulum, and where L is the equivalent length of the simple pendulum. This is the formula you have to use.